Okay, so when you're doing a redox reaction here, 24b, page 641, what you want to do is you want to figure out what the net ionic equation is. So if you have any compounds that are soluble, that aren't really together in the solution, you should try and split those up. So this is gas, this is solid, this is gas, so you can't split those up. But this is aqueous, right? Nitric acid, really strong acid, so that's going to be split up. So really what we're dealing with here, I guess, is what? This is just going to be H plus NO3, right? So you could rewrite that. Now I won't rewrite everything here, but what you can do is just rewrite this part. This is actually H plus NO3 minus. Okay? Still aqueous is fine, whatever. So that, in this particular question, that doesn't help us all that much. Why? Because we're really shedding a hydrogen there, which we're going to have to add some hydrogens later on anyway, so whether we actually have it or not doesn't matter. But what that means is, if we're looking at the N, which probably the N is going to be either oxidized or reduced here, right? Because it's not hydrogen, it's not oxygen. There's really only two choices, N or S. So when we look at the half reactions, we have to decide which one is being reduced, which one is being oxidized. That's how we split them. Okay? So let's take a look at now just NO3. Okay, the N in NO3 changes to the N in NO. So is this, is there a change in electrons here? So the first thing you want to figure out is oxygens are almost always -2, right? So 3 times -2 is actually -6. We have 6 negative charges kind of bound up in the oxygens here. The overall charge is -1 on this ion. So what's the charge on nitrogen? It is +5. You see that? So nitrogen here is an oxidation state of +5. Okay. What about over here? Well, we said that oxygen is -2, and there's only one of them. And so here nitrogen is +2, right? Because it's a neutral species. So what's happening to the nitrogen? Is it being oxidized or reduced? Because something is happening to it, right? It's being? Which one? Okay, so let's review. So lose electrons is oxidation. Gain electrons is reduction. This goes from a +5 to a +2. So it's actually gaining which one? Electrons. Yeah, it's actually gaining electrons, so it's reduction. The other thing you look at is just the charge itself, or the oxidation state. If it goes from +5 down to +2, that charge is being reduced. So that's a reduction. You can look at it that way too. All right. So then, is this a what, sir? The +5 is the oxidation state for nitrogen in this compound.
That's not like how many electrons?
Yeah. It represents sort of how many electrons are attached to nitrogen in this compound. And then see the electrons for every nitrogen here, we've got sort of an overall +5 state. Over here on the other side, it's kind of an overall oxidation state of +2. So that means that there's 3 electrons that have gone somewhere. Or I'm sorry, that it's picked up. It's picked up 3 electrons from something else in this reaction. Okay? So it's just kind of the 5 doesn't mean it has 5 electrons, or it has, you know what I mean? It doesn't really mean that. It just, we're comparing the state from the beginning to the end. Okay? And so when we compare oxidation states for an element from the reaction side to the product side, we can see whether it's given up electrons or it's received them, gained them. Okay? Does that help? You're just using those numbers to see where the electrons have been transferred. So it'll make sense too when we look at the S, because the S is going to be the other one. Okay? So what you want to set up is the reduction half. So the reduction half reaction, and that's going to be NO3 minus, and that goes to NO. NO3 minus to NO. This represents the species involved in the reduction half of this redox reaction. So that's reduction half. So let's go over here. Oh, we want to do that red. So let's do oxidation half. Okay. So again, S is the other one you want to focus on, right? We have an oxidation state of 0 here. because it's neutral. It's an element by itself, no charge. And over here, H is +1, and there's 2 of them. So that's an overall kind of positive 2 oxidation state here for hydrogen. And so sulfur is going to be -2. Very good. Okay, so we've got a -2 going to 0. So that has what? Lost electrons. Okay. So H2S has to stay as H2S because it's a gas. It's not aqueous, right? We'll just leave it as H2S. And then over here, this is going to just S as a solid. Okay? So any questions about determining which element and therefore which sort of species is reduction half and which is oxidation half? Yeah, so what happens to this H here is question. It's okay just to leave that for now because we're going to have to add in H's and waters and all that sort of stuff later on, so that we'll take that into account. Yeah.
Is there a transfer of electrons from one to the other one?
Yeah, that's right. So we're gaining electrons on this half and losing on this half. So the electrons are basically jumping ship here from this one over to this one, really, right? And so there's a transfer of electrons. Well, okay, is it 3 that just jump from there to there? We have to go through the process, okay, to see exactly what's happening. So you don't know anything from here, really. Don't worry about it. Let's just follow the steps, and then the electrons will balance themselves out, okay? All right, so back over here, we have to balance everything that's not hydrogen or oxygen, right? So the ends are balanced, so we're good. We don't have to touch anything here. And I'll just focus on the reduction half first. So what's the second step there? Somebody read that out for me. What's the second step? We balance what next? Oxygens, yeah. We balance oxygens next. So there's 3 over here, and there's only 1 over here. So how do I balance the oxygens? I add what? I add water. So I'm going to add H2O over here. And how many H2Os should I add so that the oxygens are balanced? Yeah, I'm going to have to add 2 more. That's right. Okay, so that's 2 oxygens plus 1 oxygen is now the oxygens are balanced. Everybody good with that? Okay. Okay, so I've added water, so I've got an imbalance of hydrogens now. So now I have to balance the hydrogens, right? Is it hydrogens next? Mm-hmm. Right? Okay. So I've got 4 hydrogens over here. So in an acidic solution, I should say, make sure we say that this is acidic, okay, in acidic solution. So we have lots of H pluses that we can use. And so again, that's why this didn't really matter if we dropped that at the beginning, because we're going to add a bunch here anyways. So if we had the H here, you know what I mean? We'd only have to add 3, but we actually know. So we're going to add 4. So 4 H plus ions to this side, okay? So this is what we have so far. I'll just write it in order. Okay. So what's the last thing we have to do to balance the half reaction part is take into consideration what? The electrons, right, okay. So how do we know how many electrons are really involved once we balance all the other things? Well, you take a look at the charges. So I have 4 plus charges here wrapped up in these hydrogens, right? And I have 1 minus charge wrapped up in this nitrate. And so overall that is 3 plus, right? So where do I need to add the electrons to represent a balance or to make everything neutral? Because over here this is 0. That's neutral, right? So where do I have to add the electrons? Which side? Sorry? Yeah, the side with the H is the side with the positive. See that? So you see how I have to actually add 3 electrons here? Okay? 3 electrons. So that actually works out pretty good, right? We have +5 and +2, so that is 3 electrons, okay? But we've got everything else balanced too, so that's the process. That's how we know.
So it won't always be like first here it's 3, but it won't always be that?
It depends if we have to balance these at the beginning or not, right? So that's kind of, if we don't have to change the number of ends, then that would be the case. Yeah. Okay. All right, so what that means now is that I have just this in blue, right? Okay, so I have this plus 3 electrons produces this and this. Okay. Now, does that make sense? This is the reduction half, so it's gaining electrons. Well, if plus 3 electrons are on the reactant side, that means that those are picking up electrons, are being involved in the reactant side, right? So they are being gained. Okay, let's go over to the other side then.
Wait, can we know where this is going yet? Or is
No,
that-
no, don't worry about just that's good for that half. So this is the first half reaction right here, okay? Now we're going to focus on the oxidation half. So we go back to the rules. Are the S's balanced? Yes, they are. Okay. Are the O's balanced?
No.
Well, there's no O's here and there's no O's there, so we don't have to manufacture anything. So the O's, I guess, technically are balanced, right? 0 and 0. So what about the hydrogens then? I have to balance the hydrogens. So I'm going to put some H pluses here. And how many H pluses should I put over here? 2, see? So 2 H's here, 2 H's there. Okay? So again, follow your steps there that I gave you in the notes there. Those steps are important. Question, or are you guys good? Okay, so now it's electrons, right? It's oxygens, hydrogens, it's electrons now. So we have 2 plus charge over here, and we have a 0 charge over here. So I need to add 2 electrons over here. Okay? 2 electrons have to go over there. You good with that? So now this half is completely balanced. It's balanced with respect to atoms, right? The H's and the S's, they're all balanced. It's balanced with respect to charges and electrons, right? With the charges there. So atoms and charges. So now what we have to do, the next step is we have to get this to a point where we can add the 2 half reactions together, but the key is that the electrons cannot remain in our final cut, right, in our final equation. So we have to make sure the electrons are going to balance off. So I have 3 electrons here and 2 there. So this is where you can multiply the whole equation, and we want to get a common denominator of electrons, or a common value of electrons. So I'm going to multiply this by 3. I'm going to take 3 of everything that I have in this half, and I'm going to take 2 of everything I have in this half to make the electrons balance out. So here in this blue down here, I'm going to do that. So 4 hydrogens becomes 8 hydrogens. 1 NO3 becomes 2 NO3s. 3 electrons becomes 6 electrons. And so on. 2 NO plus 4 H2O. Over here I've got 3 H2S produces 3S plus 6 hydrogen ions plus 6 electrons. Okay? You okay with that step? So the electrons are on the opposite sides. You're doing things right. Now the number of electrons are equal. So now we can go ahead and add the equations. And I like to add the equations kind of like one on top of the other. I like to putting them on top of the other. So if you want to just rewrite one, put it underneath, make the arrows sort of line up a little bit, that would be a good idea. I'm just going to, with the powers of technology, I'm just going to do this like this. Put this down here in the middle. I'm going to grab this one as well. And I'm just going to kind of arrange these guys over here so the arrows are kind of right above each other. All right. So you want to make sure you have all your charges on here properly. Again, the states of matter, yeah, kind of important, but I don't want to mess up my, get it too complicated right now for you. So when you get to this point, you should see 6 electrons, the same number of electrons on both sides of the final equation, right? You see, we're really just adding them. See, this is what we're doing, adding them. So if there's anything that's the exact same on both sides, we can like basically cancel those off, right? So waters, well, there's no water there's waters over here, but no waters over here. So really that water is going to stay, okay? It doesn't matter the order, so let's put the waters there. We notice that So that's going to stay like that. The hydrogens. Okay, so we look at the hydrogens. There's some hydrogens on both sides of the arrow, right? So if I cancel off what I can, all 6 of these go with 6 of these, and I'm left with 2 hydrogens here. Okay. Now, is there anything else that's the same? Nope, doesn't look like it. So you could just go ahead and rewrite everything that remains. Okay. On this side we have, doesn't matter the order, doesn't matter. And again, the states of matter, probably a good idea, but I'm not so worried about the states of matter here. I'm just worried that you get these species, and the charges are pretty important too. So let's see here. Let me just now. I'm going to double check my work. That's exactly right. That is the answer. Okay. So again, that's how you balance a redox reaction, a half reaction method. That's 24B in your text, page 641, Merrill Chemistry.